Today I want us to look at what is indices. What is indices? So in the expression a to power m, the number represented by a is called the base. So in a to power m, a is called the base of the expression, and the m is the index or the power to which the base is raised. So in plural, index is indices, meaning indices is the plural for index, and index is a power. It also means power. Therefore, we want to look at the laws of indices. What are those laws that govern indices? The first one, we call it the multiplication law. The multiplication law tells us that if I have 3 to power 6 times 3 to power 4, we can expand it as 3 times 3 times 3 times 3 times 3 times 3. We multiply it with expanding 3 to power 4 as 3 times 3 times 3, 4 times. So meaning if we count how many 3's, we end up having 3 to power 10. However, clearly it is not necessary to write down all the 3's like that. So all we need is to add the powers. So you add 6 plus 4, we get 10. Therefore, and so 3 to power 6 times 3 to power 4 is actually 3 to power 10. Then this can be written in general form as our first law, as when you have a to power m times a to power n is actually a to power m plus n. So we add the powers. A to power m times a to power n is equal to a to power m plus n. We add the powers. That is the first law of indices. If you look at the next law of indices that talks about division, so if we divide 3 power 6 and then we divide it by 3 to power 4, we can get, so we do the expansion as normal, and now when we do the expansion, 3 times 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3, we shall end up having 3 to power 2. So in this case, you subtract the powers, so which is 6 minus 4, which is equivalent to 2, and so 3 to power 6 divided by 3 to power 4 is actually, we subtract the powers and we get 3 to power 2. This means we can write it in general form as a to power m divided by a to power n is actually a to power m minus n. Now that is our law number 2. Law number 2. Now if we look at law number 3, if you look at law number 3, don't forget to subscribe and like this video if it is helping you. Let us look at law number 3. If you look at law number 3, the power of powers. So if a base is successfully raised to 1 power and then another, as for the example, we have 3 to power 4, then power 2, we can write it in an expanded way, that 3 to power 4 squared is actually 3 to power 4 times 3 to power 4, which can be expanded. Counting those 3's give us 3 to power 8. And then, in this case, the power to which 3 is raised are multiplied, therefore, 4 times 2 we get 8. So we can write this in general form as, if you have a to power m, then power n, it is equal to a to power m times n. So you multiply the powers. So looking at the next power law, which is the power 0. Power 0, for it tells us that if you divide 3 to power 4 by 3 to power 4, for example, the answer is 1. This is a number divided by itself. So meaning, so we can use the law number 2 of indices. We can also carry out division and say that 3 divided by 3 to power 4 divided by 3 to power 4. We can subtract the powers and gives us 3 to power 0. Therefore, this follows that 3 to power 0 is actually 1. Now we can write this in general form, and this becomes that any number to power 0, a to power 0 is actually 1. So any number to power 0 is 1. So if we look at our last law, don't forget to subscribe and like if you are enjoying this video. Our next is the negative indice. Negative indice tells us that if I dividing 3 by power 4, if we divide it by 3 to power 6, this gives us an expansion form. So we have the 3 times 3 times 3, which is 3 power 4 up and 3 power 6 down. So which when you subtract the powers, we can get actually what is equivalent this other side, which is 1 out of 3 times 3. So this means that 3 to power negative 2 is actually 1 out of 3 to power 2. And this in general form, we can say that truly a to power negative m is actually 1 out of a to power m. Don't forget to like and subscribe to this channel if you are being helped in this. Thank you so much. So those are the laws of indices. Thank you so much. May God bless you.